Right. Right. Thankfully, I have the slot between you and lunch. So we're going to try and make this a reasonable pace. And I'm extremely miffed that Sam got the first reference to fridges into the proceedings. But she looks really excited. So just to let you know what OpenTRV does, we do thermostatic radiator valves. They're really, really exciting, just as exciting as fridges, honestly. Yes, completely. So ours is a connected thermostatic radiator valve. It has sensors in it, and it detects whether or not you're in the room. And if it thinks you're not in the room, and it thinks you're not going to be in the room soon, it will take the temperature down. So for example, you wake up in the morning, you have a nice toasty bedroom, you then leave, it will take the temperature down because it thinks you're not coming back. But by the time you get back there in the evening, it will have brought the temperature back up again because it thinks you're coming back in. Now, the reason why OpenTRV exists is climate change. We're here to combat climate change, and that's the way we're doing it. But the other thing we have to do is make sure that we're doing this at a price point that makes sense. So we're looking to produce these things ultimately, because it's not there yet, at £10 a pop. And we're going to attempt to knock 10% off the entire UK's carbon emissions for £10 per radiator. So that's OpenTRV. However, as part of that, we need to reduce the cost of the Internet of Things, because this is a connected thermostatic radiator valve. And an interesting option for us to reduce the cost of communications is to make it free. And everybody loves free. So this is where the Things Network comes in. Now, this was brought about by some Dutch guys. They basically said, there's this good technology out there, let's see what we can do with it, because it would be a really good thing if we could have some community-based networks out there. Now, here's your traditional Internet of Things network, and I don't know how I can get away with calling it traditional, since they've only been in existence for 2 to 3 years like this. But if you go back to M2M times, still the same. Basically, fine, we have things at the top, gateways, receiving the data, a gatekeeper that charges you money, and there's your applications. And so, quite simply, the bit in the middle is the bit that we concern ourselves with, because they look like this. They take money from you. So we'd like it to look like this, where they don't take money from you. So that's the mission of the Things Network, is to build this network out across the entire world, decentralized, so there's no one central point of failure, make it open to everybody, make it usable by everybody, carry all data agnostically, and that's effectively crowdsourcing a network. There's a manifesto on GitHub. It was great. It started off with some Dutchisms in there, which is, you can go and have a look. It's deliberately made too small, so you can't read it, but it's there if you want to find it. And the underlying technology in this one is LoRa. LoRa stands for long range. It's owned by a company called Semtech in the States. They're a large analog semiconductor manufacturer. They make plenty of radio chips. It's actually a French technology. It was invented in Grenoble. And LoRa bought the technology off of the French company. All the Internet of Things networks are long range, low power, low bandwidth, low cost, blah, blah, blah. Okay, it's another one of those. There are some technical reasons why this one is particularly interesting. As a technical person, I can go into it with you if you're that interested, but I'm not trying to do the technical characteristics today. It's more the thought about the community. We can get a decent number of devices per gateway. That's one of the key features of the technical side of LoRa. There is a protocol within LoRa that they have defined for the software part of this called LoRaWAN, and it's good at managing the number of devices you can fit on a gateway, particularly with some magic stuff like chirp spread spectrum modulation, adaptive data rates, things like that. So that network management layer is key, and that's what we'd been struggling with as a company to understand how we would be able to interact with that network management layer and not pay too much money for each of the devices, or even a toll per device. So this is some of the software architecture behind what the guys in the Netherlands are currently writing. Here we have some routers. There we have some brokers. This is going to handle your security. It's a handler, and this is your end application up there. By the time you've added all these lovely bits of software together, you get your data. It's carried across a network, which is secured with AES encryption from end to end. There's actually 2 layers of encryption in the LoRaWAN spec. The first layer is from the application to your device, and the other way, the device to the application. So that encryption is under your control. The second layer is the network encryption layer, which you can think of as, here's a packet and here's some routing information, but you can't look inside the packet. Now, the difference between what a telco would offer and what the Things network is offering is the Things network is giving you that key. You can put your own gateways up. You can put one up in your house. You can persuade other people to put networks up, put gateways up. You can mesh all these gateways together to provide a universal service, because they're sharing their network key with everybody else. Now, we should be able to do exciting things like triangulation, depending on how many gateways we get up and out there. And then the other trick with the network management is going to be putting new devices in the right places to ensure coverage, even when the number of devices multiply. And that's going to be quite a trick if they pull it off. So, Amsterdam. Typical Dutch fashion. It's, yes, let's just give it a go. They go out and persuade a whole bunch of companies to put gateways up. That's the result. These companies put up gateways, and Amsterdam is covered. Now, the range of this thing is somewhere between 2 kilometers in a city environment and 10 kilometers in a rural environment. Utterly depends on all of the metal and concrete and everything else that's in between the node and the gateway. It's not going to be much different to all the other IoT low power wide area networks that you run into, because they're all based on similar kind of technology with similar kind of constraints. But having done this in an open way means that even if you are the Port of Amsterdam, up the top there, that's not where the Port of Amsterdam finishes. Some of the stuff that they want to monitor, they monitor through some of the other gateways, because the waterways continue further. But they've been able to just put up one gateway to cover most of the area that they're interested in, and use other people's gateways to do the rest. Seems to me like an obvious thing to do if we can do it. Same with a whole load of other people. Can you read those? Just about. It's going all over. Sorry?
Why is London not on there?
Getting to it. It's all over the place. Okay? It genuinely is happening all over the world. Some of the more entertaining ones. So you can do it in Uruguay, you can do it in Argentina, you can do it in South Africa, you can do it in Brazil, you can do it in the States, and there's a whole load of European ones. And you might notice Thatcham. How very exciting for Thatcham. So yesterday I was prancing around on top of 101 Euston Road, which is the digital catapult, plonking this gateway up there. This is one of the more expensive gateways you can buy, but hey, you can see the City of London, you can see St Paul's, and there it is. It's available. It's working. Anyone who wants to use it, go for a walk down Euston Road. There it is. Your data will appear on the internet, on the Things network, if you wish encrypted. If you don't, it's there available for all to look at. Reason why we're doing it is because we're running a project at the moment with Innovate UK, and we are looking at footfall in bus shelters. And we're also interested in looking at footfall in bus shelters in the Shoreditch area, which I'll get to in a moment. But basically, between the span of King's Cross, St Pancras, and Shoreditch. But there's another rather cuter little application, which the part I like about this is the community parts and the business parts, and I figure that the community parts can get supported by other harder applications on this. We are talking about a mixture of hedgehogs and circuit boards and araldite. And when those three things come together, you have a hedgehog tracker. So the little chaps and chapesses are running around in Regent's Park, and there's a prof from the Royal Parks who's doing a study and is interested in whether or not we can come up with some lighter trackers that are slightly more reliable than the ones they currently have. So the current ones are GPS, and they have a problem with the battery drain. So we're looking at it, and we're currently debating whether or not we can support them. So here's the appeal. Help the hedgehogs, please. But if that's not enough, we could do with sorting out some legal stuff. There will inevitably be some scary legal bits and pieces. Any of the open source community-minded lawyers that you might know, please put them in touch. We are looking for a site in Shoreditch on a reasonably tall building. We'd like to put another gateway up there and hook into someone's network connection. If anybody knows somebody, could they please get in touch with me? And just your connections and your thinking of the people in this room, the people who are interested in the Internet of Things and are interested in community-based networks, please have a think on whether or not there's stuff to do. There's a website, thingsnetwork.org. There's an active forum. Jump on there and help out. And then this is the thing that it reminds me of. Right at the top, you can see that chap's name, John Postel, one of the fathers of the internet, 25th of February, 1982. This is how it feels to me. We're at that nascent part of the internet, but this time the Internet of Things. And that agnostic internet that came about and has been used by all of us, that's what the Things Network feels like to me right now. So that's it. If there are any questions, please come and find me. And I hope, wherever James has gone, that we're probably doing lunch next. Fintan, you might be next.